Question number 4. For the circuit of figure 3.46, letter A, count the number of circuit's elements. So, for us to know the number of circuit elements, we will count the number of nodes. 1, 2, 3, 4, 5, 6. 6 circuit elements. B. If we move from B to C to D, how we form a path, how we form a loop. Obviously, it forms a path. Letter C. If we move from E to D to C to B, how we form a path, how we form a loop. If we move from E to D to C to B, it will form a loop.
For number 8, determine the current labeled I, which is current in each of the circuits of figure 3.50. So, the figure has 3 parts, letters A, B, and C. And for letter A, in determining the current, we just use the KCL from this loop. So, that is 7A minus I and minus 6A. So, transposing the variable I, we get the current to be 1 amperes. And for letter B, same goes. We use the KCL and we obtain negative 3A minus I minus A. So we get the value to be 6 amperes. And for letter C, the current is equal to 0 amperes.
KVL to obtain a numerical value for the current labeled I in each circuit depicted in figure 3.59. To be able to combine the voltage sources, they must be in series. Since the same current I flows through each, this condition is satisfied. Starting from the bottom left-hand corner and proceeding clockwise, the total voltage is negative 1 plus 2 minus 5 is equal to negative 4 volts. Replace the 3 voltage sources with a single negative 4 volt source having its negative reference, as shown in figure 2. Apply Kirchhoff's voltage law combined with Ohm's law to the circuit in figure 2. Negative 4 plus 2i plus 10i is equal to 0. 12i is equal to 4. I is equal to 4 over 12 and the final answer is 0.33 amperes. In part B, consider the following circuit. To be able to combine the voltage sources, they must be in series. Since the same current I flows through each, this condition is satisfied. Starting from the bottom left-hand corner and proceeding clockwise, the total voltage is 10 minus 1.5 minus 1.5 plus 2 minus 1 is equal to 8 volts. Applying the Kirchhoff's voltage law combined with the Ohm's law to the circuit in figure 4, 8 plus 2i plus 2i plus 2i plus 2i is equal to 0. 8i is equal to negative 8. I is equal to negative 8 over 8. Our final answer is negative 8, 1A amperes.
So for our next problem, problem 26, obtain a numerical value for the power absorbed by each element in the circuit shown in figure 3.65. So this is figure 3.65, and we have 4 elements. Let's say this is element 1, 2, 3, and 4. First, we will get the value for VA in order for us to get the power absorbed by these elements. So our first solution, we will be using KVL or the Kirchhoff's voltage law. So for V1, we have positive 4.5 volts minus 2 ohms times current minus 8 VA, and our voltage 4 is plus VA. So we will combine this and transpose V1 to the other side. So we have negative 2 ohms times current minus 7 VA is equal to negative 4.5 volts. Simply, we have 7 VA plus 2 ohms times current is equal to 4.5 volts. So this will be our equation 1. For the next equation, we will get the voltage across this resistor. So we have VA is equal to resistance times current. So VA is equal to 5 ohms times current. This will be our equation 2. We will substitute this equation from our equation 1 in order for us to get the current and the value for VA. So we have 35 ohms times current plus 2 ohms times current is equal to 4.5 volts. So current is equal to 4.5 volts all over 37 ohms. The value for our current is 0.122 ampere. So we will substitute this from our second equation, which was VA is equal to 5 ohms times current. So 5 ohms times 0.122 ampere is equal to 0.61 volts. So this will be our VA. So now let us solve the power for each element. So this is our circuit. First, we will get the power in this element. So for 4.5 volts, the formula will be power is equal to voltage times current. So our voltage is 4.5 volts and the current is 0.122 ampere. So the answer is 0.549 watts. So in this element, for 2 ohms, the formula is power is equal to I squared times resistance. In current is 0.122 ampere and the resistance is 2 ohms. So the answer is 29.768 milliwatts. So for our next element, we have 8 VA or 8 times our VA, which was 0.61 volts is equal to 4.88 volts. So the formula for power is voltage times the current, wherein our voltage is 4.88 volts and the current is 0.122 ampere. So the answer is 0.595 watts. And for the last element, we have the resistance 5 ohms. So we will be using power is equal to I squared times R, wherein current is 0.122 ampere and the resistance is 5 ohms. So our answer will be 74.42 milliwatts. So that's all. Thank you for listening.
So, for the first number 43, determine the conductance of the following. And for letter A, the given resistance is 0 ohms. So, the formula for conductance is 1 over the given resistance. That's why 1 over 0 ohms. So, the conductance is infinity, since 1 divided by 0 is cannot be and equals to infinity. So for letter B, R is equal to 100 mega ohms. So just like in letter A, we substitute the given resistance to the formula 1 over R. So 1 over 100 mega ohms is equal to 1 over converting it to ohms, 100 times 10 raised to 6 ohms. So the final answer, the conductance is 10 Siemens. For letter C, 200 milliohms. Same process will be substituting the given resistance to the formula. And we get the final answer to be 5 Siemens.
Problem number 54. The resistance values in table 2.4 are calibrated for operation at 20 degrees Celsius. They may be corrected for operation at other temperatures using the relationship R2 over R1 is equal to 234.5 plus T2 all over 234.5 plus T1, where T1 is the reference temperature, T2 desired operating temperature, R1 resistance at T1, R2 resistance at T2. Problem. A piece of equipment relies on an external wire made of 10-8 AWGs of copper, which has a resistance of 50 ohms at 20 degrees Celsius. Unfortunately, the operating environment has changed, and it is now 110.5 Fahrenheit. Letter A. Calculate the length of the original wire. Letter B. Determine by how much the wire should be shortened so that it is once again 50 ohms. Solution. 28 AWG is equal to 65.3 ohms per 1000 feet. For length, 1000 times 50 all over 65.3, which will give us 766 feet. 110.5 Fahrenheit is equal to 43.61 degrees Celsius. Using the formula a while ago, the resistance 2 can be get as 234.5 plus 43.61 times 50 all over 234.5 plus 20, which equals to 54.64 ohm. For letter B, 50 times 766 all over 54.64, which will give us 701 feet.